Good afternoon, guys. Welcome to the session. So, as we know, we were seeing domain analytics, which is from 360DigiTMG. So, in domain, we were seeing automative analytics, guys. So, the day one, we have seen what is our agenda, introduction, everything. So, in the day two, we have seen what all the challenges we are going to face, right? What are the concepts? What are the next concepts we are going to learn? So, what is meant by this machine learnings? What type of machine learnings we have? As you see in the previous session, guys, we have seen about this measure of central tendency, measure of dispersion, and many more, right? The fourth moment business decisions we have seen, and we have gone through that. And in the yesterday topic, we have seen the machine learnings. So what type of machine learnings we have, right? So unsupervised learning, supervised learning. So in today's session, in day three, we'll be seeing the difference between supervised learning and machine learning, as well as what is this EDA? What is this? Why we need this EDA? What is meant by data pre-processing? Okay. So just to do a quick recap. So in day one, guys, we have seen what is meant by automative analytics, right? So why we need this automative analytics? What is meant by automative analytics? So how we are going to implement that? So what is the definition of that? What is the conclusion? What are the challenges we are going to face? So these things we have seen in day one. Coming to day two, we have seen what are all the things, what is this machine learning, so what are the agendas, so what is CRISP-MLQ, right? So when I go to the mind map, so you can see the one, what is business understanding, we have seen in day one, right? We have seen what is this business objective, the constraints, the success criteria, why should we use this recommended optimization words like minimize and maximize, what is project chatter, right? So this is our mind map, guys. So I say day by day, so always remember to go through the mind map daily once, guys. So it makes better. So you get all the knowledge which is required for data science field. So as I said, we don't have only data science map. We have different mind maps also, which is keep on updated when the updates are coming through. Okay. So and data understand. So we have seen what is meant by data understand. So we have seen the types, what is the data collections like primary and secondary source, right? And data types also we have seen this continuous, discrete, qualitative, quantitative, big data versus non-big data, the cross-sectional. We have gone through all that and we have seen the definition of that. So what is it's gonna indicate? So what is meant by that, right? So after that, we are gonna go for data preparation. So yesterday we have seen what type of data cleansing, data preparation, right? So guys, in day three, what we are gonna see, exploratory data analysis, okay, and data pre-processing. So guys, we are going to learn about this exploratory data analysis as well as machine learning types. So data cleansing, data preparation, we have seen what is meant by typecasting, right? Converting one data type to another, handling duplicates, this outlier analysis treatment, zero and non-zero variance, missing values, and so on. So this type of data preparation and data wrangling or data cleaning, you can say, okay? So we have gone through this. And after that, what we have seen, exploratory data analysis, right? So we have seen first moment business decision, second moment business decision, third moment, fourth moment, and so on. So how we are going to implement this? So I have explained you about it. So today we'll be seeing the feature engineering, okay? The data preparation basically, okay? We'll be going with supervised learning and unsupervised learning models. Okay, so why do we need this? So in the day two, we have seen what all our agendas, so how we are going to work with, so what type of techniques we are going to use in this data science, how it is going to evolve, what is the motive we are going to get in that, right? So what is the advantage if we learn this domain analytics, what we are going to understand. So guys, when we are going for day three, we're going to go for data preparation. So in data preparation, we'll be seeing different type of data preparation, data cleaning, right? So typecasting, it may be handling duplicates, it may be outlier analysis treatment, right? So outlier analysis treatment, guys, I have explained you, right? So all the data sets are, one point, and one more data point is far behind from that is called as outlier analysis treatment. So how we are going to solve that? So what type of things we are going to use, right? So guys, going to data preparation, right? So let me go to the slides. So automative analytics, guys, data types. So I'll be explaining more deeply about this. So as I know yesterday, I just gave an introduction of that. So data types. So we have seen data types. What are data types, right? Different type of data types we have. typecasting, we have outlier analysis treatment, right? We have handling duplicate, zero and non-zero variancy. So let me show you how where it is. So guys, these are things we have seen: typecasting, handling duplicates, outlier analysis treatment, zero and non-zero variance, and discretization, dummy variables, transformation, standardization, and many more. Right. So after that, we are gonna see what type of things we are gonna do. Okay. So why do we need this? Okay. So why we need to clean our data? Can we get the data which is clean first only? Can we get the accurate data? See guys, when you're gonna collect the data will not be available in all the things, right? Okay, let me say there will be a null value, there will be some missing values, right? So that is the reason we are gonna use this data cleanness. Okay. So data cleansing guys. So we have all different types, dead data types. These are called as data types, guys. Typecasting, handling duplicates, okay, and dummy variable creation, transformation, and many more. Okay. So guys, after that, I'm gonna see, okay. So why do we need these things? Okay. Why do we need this dummy variable creation, transformation? Okay. So after that, I'm going to see standardization or normalization. Okay. So as I said, if you are more comfortable to read more, guys, you can always go to the blog. Okay. So when you click on this link right here, so you can go to the blog if you are more interested in reading, right? So see the data cleansing. So you can see what type of things we are going to see. Okay. So you can see what type of data analytics we are going to use. Okay. Okay. So we have standardization, and we have different type. Okay, so duplication and zero non-zero variety, structured versus unstructured data. So I said to you guys what is meant by structured and unstructured data, right? So this which has in tabular and formats, right? That is called as, so that is called as structured data. Okay, unstructured data. Okay, and we have seen that, and we have seen what is meant by unstructured too. The unstructured is nothing but images or videos, right? And cleansing methods, outliers or extreme values. Okay. And if you go, what is, as I said, guys, yesterday I have explained you about the Windsorization and the outliers thing, right? So outliers or extreme values. So 3R techniques we have, guys: rectify, retain, and remove. Okay. So we have three R techniques. One is rectify, retaining, and remove. So what is rectify? So yesterday I have just given you the introduction. Okay. So rectify, what is rectify? If outlier exists due to a typo or data entry errors, then you may identify the individual observations and correct it by manually setting it right. Okay. It means, guys, if the outlier exists, okay, due to a data entry errors, or you may identify the individual observation, this can be corrected by manually. Okay. How it is done? It's gonna done by rectifying. Okay. And observations, the retaining thing. In outlier exists due to intersonic change in work strategy. So guys, this you can see the example due to some natural phenomena such as COVID 2019, which is irreversibly changed. So what is mean in this scenario, guys, the repeated things, okay, it's gonna utilize by feature purposes. Okay, in these scenarios, we're gonna retain outliers and we're gonna use them separately. Okay, so we know COVID suddenly came. Okay, it was not existed, but some we can say due to some natural phenomena, the COVID-19 was existed, right? Suddenly it came to the COVID 2019. Okay, and remove. What is the sense of remove? It's going to do. So the remove, the outlier exists due to some statistical activity or non-repeating random phenomena. Then such value should be removed from the data set. So here, what is in the sentence describes is, so the outlier exists due to some activity, okay, or non-repeating random. So I can say the outliers is existing due to some tactical activities and some errors, some data entries, different type of errors. Okay, then such values should be removed from the data set. Okay, so we know we are going to use this PR technique for outlier analysis treatment, right? So guys, this outlier analysis treatment, we are going to use this. And next, visualization. So yesterday we have seen the 95%, 85%, right? So when you go to the mind map, Okay, when I click on this standardization or normalization, okay, you can see it will make scaleless, free, and unitless. Okay, and we have different type of thing. And you can go for this transformation. We have check for normal distribution, square root, and everything. So guys, when I go this minimum maximum scaling thing, we have minimum and maximum. Okay, and the library is sklearn.preprocessing import minim and maximize. So here, this winsorization is alpha trim or winsorization. Okay, if we have outliers in data set, okay, so we can apply the alpha trim method to treat the outlier. Depending on the context, you may remove 5% or 10% from the data. So guys, when you have a data, you can't remove more than 20. Okay, so here they are saying we have 80% of data. So I'm going to remove my outliers 10% or 5%, not more than that. We're not going to exceed more than that. Okay. So winsorization is nothing but trimming is nothing but we're going to trimming is different, right? And winsorization is different. Okay. Trimming, we're going to trim down the data. There might be a loss of that. But winsorization, we are going to remove the data. Okay. Means we are going to remove only the data which is not necessary. Okay. So masking. So guys, when I explained about masking, so we know it is not able to detect out. So when you go to data mind map, guys, you can see masking. Okay. So let me show you masking. Okay. So when you go to outlier analysis treatment, we have 3R technique and masking. So masking, you can see outlier exists but fail to detect. So what is it is describing? So outliers are there, but it is not able to detect. Okay. So when you go to here, you can see there could be multiple outliers existing in the data set. A box plot might not give a clear picture of how many outliers are present in the data set. It may also happen due to presence of second outlier that doesn't allow the outliers test to find the first one. This is called masking. So guys, here you can see an outlier is present. Okay. Here you can see an outlier is present, but the masking is not able to detect that. It is called that false negative. Okay. Whenever you are going to do some research, guys, always you can see false negative. As I said, outlier exists but fail to detect. Here outlier is existing, but it is failed to detect. Is called as masking. Okay. So you can see swamping, the next topic. Swamping. What is swamping? When non-outliers are classified as outliers, the phenomenon term is called as swamping. Okay. When non-outliers are classified as outliers. Okay. So here you can see how can you get an example? So swamping, guys. So let me say this is the data points which we have, but it is detecting these outliers as non-outliers. Okay. Swamping is a use of that. Detecting non-outliers as outliers. Okay. So after that, we're gonna go for missing values. So missingness in data is rampant problem. Means sometimes the data entry may be error. So let me say there was one value of 20, but by mistake he has just given a data entry. So let me say he hasn't entered anything. So that is missing values. So you can see why it is essential, this missing value. It is essential means the certain values in the data set would be missing due to various reasons. So as I said, guys, various reasons, it may be data entry error, different type of things. Okay. Missing value is not good for building machine learning models, as generally algorithms automatically drop such observation from the data set. So guys, when you're going to learn this, build this machine learning, right, it is not suitable. Why it is not suitable? Because we are going to train our model and test our model, and the data must be accurate, right? We should get a data which is we are going to use. So before going to train it to the machine learning model, okay, we are going to do this EDA process and everything. Simply we can't just go and we're not going to do EDA, we're not going to do data processing, we're going to apply it. No, it can't be done this. Okay. And this missing values, we are going to apply. Okay, missing values. And after doing EDA, after doing data preparation, then we are going to apply for machine learning. So we can train our model where we get some accuracy and everything, right? So we have different types there, guys. So I'm going to explain you about right fit model, under fit, over fit. Okay. So as we move on, I'm going to explain when you're going to move for the machine learnings. So I'll be explaining you about that also. So what is this right fit? What is this over fit? What is this under fit? Okay. So next we are going to do is mean imputation. So what is this mean imputation? So mean imputation, if we have continuous variable, then we can take the mean variable and impute them in the missing values. Okay. So mean values. So let us say there is a missing of values. So what we are going to do? We are going to take some value. Okay. We are going to do mean for it. After doing mean, we are going to put the missing values in the place of mean. Okay. Let me say there is a missing value in some box. Okay. We are going to take some continuous variable. And after that, we are going to just put it in the mean value. Okay. Wherever this missing value, we are going to just apply it to the mean. So median computation. So if there are any outliers in the data set, we cannot perform mean imputation. Okay. In such scenario, we median. So what is this, guys? So there are outliers in the data set. Okay. So we can let us say I cannot perform mean imputation. Why we can't do? Because we are going to use a logical value in place of missing values, as I said in mean. So at that time, if you want to use different method, we are going to go for median. Okay, the median thing. So you can see the median what we are going to use. Okay. And the next thing we are going to go for these imputations. We'll go later. Okay, we're going to see which is important for the domain analytics right now. So standardization or normalization. Okay. So what is standardization or normalization? So basically, it's going to make our data scaleless and unique. So the problem of unit and scale is one of the most common issues that occur in multivariate data set. In building prediction models, we must ensure that each variable influences the outcome equally. Okay. Basically, guys, this standardization or normalization is going to make our data scaleless and unit free, where we can work with the data. Okay. So that let me say the influence is what we have, right? The influence what we are going to have. These type of things we can get it from. Okay. So after that, we are going to see what is mean by this, how we are going to fix the problem of standardization. Okay. So after standardization, what we have min and max scalar of Ranger method, what we have still pre-processing, transformation, this QQ plot. Okay. So when we move on, guys, I'm gonna teach you practically, right? When we are going to implement this K means, KNN, linear regression, and so on. I'm gonna show you how we are going to implement this normal QQ plot. What is mean by QQ plot? Okay. So guys, if you have some, let me say, if you are curious, what is mean by QQ plot? Right? So always do a research, guys. So before going to other session, I always suggest you to do this thing, okay? The research. So if you want me to explain, so let me explain you today about what is QQ plot. Okay. So QQ plot is nothing but quantile plot. Okay, is a graphical technique for determining two data sets are come from population with a common distribution. So to make you understand better things, guys, so you can always consider as the QQ is nothing but quantile plot. Okay, nothing but quantile. So what is this quantile plot is going to tell? It is a graphical technique, okay, for determining if two data sets come from, let me say, population with a common distribution. This QQ plot, guys, it is a plot of like quantile for the first data set against the quantile of the second data set. In the sense, so if you want to understand it easily, guys, so you can always consider a cricket match, right? So what India has scored, the run rate, and what is other team is going to score, right? Like this, it's going to go down. So that is one line. So this is called as India. What is the score? And the red line is the other team. Okay, like this. So you can just basically imagine like this. Okay, it's a graphical representation determining two data sets. Okay, if you want to remember it simply, in the sense you can remember every time, right? So all the concepts you should make simple so you can get a grasp of it. Okay, keep an example. So when you remember that example, make sure you're going to remember all the topic. So I do like that, and if it feels better for you, you can do that. Okay. So this normal QQ plot. Okay, we're gonna see that as we're gonna see in the next applying sessions. Okay, discretization. What is meant by discretization? So it's gonna convert continuous data into discrete form. Okay, so you can see these are instances when we need to convert continuous data into discrete form. So why we are gonna need this? Okay, guys. So it is called as by binning or grouping. So this discretization is also called as binning or grouping in the sense. Okay. So why do we do that? Data is continuous. Why we want to convert into discrete form? Essentially, we build equal size interval size. We may need to do this because, let me say, like basic decision tree algorithm. Okay, we are gonna calculate. So as I know, I didn't explain about decision tree, guys. So I'm just gonna read this and make sure you just understand by this. As we move on to decision tree, I make sure I'm gonna explain this. Okay, so here you can see in a basic decision tree algorithm, we're gonna calculate the entropy for information gain. We need to have the data of discrete form. So guys, what is this indicates? So in decision tree, if we're gonna calculate the entropy, the information gain, we should always have the data in discrete form. Okay, continuous data can very easily be discretized using R or Python. So guys, what is R or Python? So why Python Python overcame R? Okay, some will be having these doubts, right? So R is nothing, guys. It is also like a Python, but it was good, well used when it was used in like statistical data. Okay, it was well used for statistical data. But this Python, okay, it was also good for statistical. But why did R Python overcame R? Only because, guys, not only one reason. Let me give one major reason. So the storage of the data. Now, the large data, it was not handled by R. Okay, so then we introduced the Python. So the Python came, the Python was introduced, and the Python was well in use. So we know the Python is everyone uses the coding, right? If you know Python, you can get a job very easily. So that is the thing, guys. Okay, in R, we use the discretized function from a rules package to convert numeric features to factors. So this education data set, okay, let me explain about this education data set. Okay, so as we move on, I'm going to show that also. So dummy variable creation. So what is this dummy variable creation? It's a categorical data with two or more classes cannot be directly used for any statistical analysis or model building. Okay, so we have variables such as type of car. So we have different type of cars, right? So when I say cars, we have petrol, diesel, CNG, and LPG. Okay, now this features needs to be utilized an input variable of prediction model. So dummy variable creation is okay. Categorical data with two or more classes cannot be directly used for any statistical analysis. Okay, so we have seen that, right? What is this dummy variable creation? Why we need this? Okay, we need data to convert into a dummy variable form that can be used in model building. Okay, so after doing this dummy variable creation, guys, it will be very useful for us to use in model building. In the sense how? So we're going to convert these categorical variables into dummy variables called as one-hot encoding. So guys, I have explained you about one-hot encoding, right? Just ones and zeros. Okay, and a critical point. So when we try to encode categorical variable, we only get one encoded features. Okay, we can create dummy variables in using R. We're going to function of dummy variables. We're going to use below R. So what are the code we have, right? So guys, we'll be seeing the code. As I said, we'll be moving on. I'm just going to explain you the theoretical things. So as we move on to practicals from the day 4, so from tomorrow we'll be seeing how I'm going to implement k-means, k-NN, and different types of things, right? So there we are going to go more theoretically, guys. So we'll get a better idea. So what I'm going to explain today, it will be very useful for the day 4. Not only today, guys. Yesterday also I explained you what is our main aim, right? What is our agenda? What we have to do in automative analytics. So in case if we have missed any session, you can always watch the recorded sessions, okay, which is available. So after that, guys, so after that, we are going to see why we are going to use this. Okay. So duplication, we have seen. So after duplication, we are going to see zero and non-zero variance. Okay, zero and non-zero variance. So zero and non-zero variation. This variance, guys, the features. Okay, if any variable has got constant variance, such as the age of all people in the business until is 28. Okay, so I'm not going to read out, guys. So let me say zero and non-zero variance. Okay, so it will add no value. So let me say there is one value with same video and one value with another video. So what we'll do? So we are going to replace zero and non-zero variance, right? it will add no values. These values are same. Okay. So guys, this was all about things, the blog which we have seen. Okay. So moving on, guys, we're going to the mind map. So guys, as I say, mind map is very important. Okay. I'll suggest you to go to the mind map every day and make sure you remember everything. So after that, we're going to go for exploratory data analysis. So first moment visitation. So I'm going to just do a recap as I know we have discussed about this, right? So measure of central tendency, measure of dispersion, skewness, and kurtosis. So guys, we have four types of this. Okay, four type of this. The business decision. Okay, one is measure of central tendency, measure of dispersion, skewness, kurtosis. Okay, and many more. So guys, what is this first moment business decision? So we have seen right mean, mode, median. Okay, so when you double click on that, you can see guys. Okay, and the next one we have is second moment business decision. Measure of dispersion, where we have variance, standard deviation. Okay, so guys, why it is important? Why we are going to use this moment of business decision is it is very important in aspects of learning. Okay, while we are doing this EDA, the first moment of business decision, the min and max. Okay, in while building this machine learning models, it is very useful for us. Okay. So guys, after that, we are gonna go for model building. Okay. So model building. So what is this model building? Is also called as data mining or machine learning. Okay. It's called as data mining or machine learning. So guys, today we'll be seeing about so we'll be seeing about different type of machine learning. Okay. We'll be seeing different type of machine learning. So we have supervised learning, unsupervised learning. Okay. And we are going to see what type of things. Okay. So what is this machine learning? Okay. So why we are going to use this? Okay. So guys, whenever I say machine learning, okay, whenever I say machine learning, you should always think about, okay, the machine learning, what type of machine learning? Okay. Okay. So we are going to see what is this machine learning. Okay. So supervised learning. Okay. So what is meant by this supervised learning? So guys, whenever I talk about machine learning, so let me explain you about what is meant by machine learning. Okay. So what is this machine learning? Machine learning is a field of inquiry, okay, devoted to understand building models. Okay. So machine learning, we are going to use that. Okay. Okay. So we are going to see this, how we are going to apply this machine learning. Okay. So this machine learning, guys, the machine learning. Okay. So the building methods, okay, improve performance, okay, some of it, some to get tasks, okay, the artificial intelligence, all these type of things, guys. Okay, this machine learning is a field of inquiry. Okay, where we are going to building methods that learn. Okay, so guys, machine learning. So we have seen what is meant by machine learning. So we are going to see what is this machine learning. The supervised learning is. Okay, supervised learning. So guys, supervised machine learning is nothing but it is the data which has labeled data sets, okay, where the available data consists of labeled examples. Okay, so if you ask me the exact thing, what is meant by this machine learning, right? This is the supervised learning. So guys, so let me explain you about this supervised learning. Okay, so supervised learning. So supervised learning, guys. Okay, so let me write it properly. So we're discussing about supervised learning. So supervised learning, what is mean by this? So guys, supervised learning is also known as supervised machine learning. Okay, guys, whenever I say machine learning, we have different types, but the types which is very important to us is supervised learning and unsupervised learning. Okay, so supervised learning. So this supervised learning is also called as supervised machine learning, is a subcategory of machine learning and artificial intelligence. Okay, it is nothing but it is subcategory of this machine learning and artificial intelligence. Okay, it is defined by its use of labeled data sets to train algorithms that to classify data or predict outcomes accurately. Okay, so it is defined by use of labeled data sets. Basically, we're gonna use this. Okay, so these algorithms, like the train algorithms, that we can classify data or predict outcome very accurately. So guys, this supervised learning. Okay, so this supervised learning. So if you ask the example of the supervised learning, you can always go with the predicting of house prices. Okay, so how it is achieved. Okay, so we'll be seeing that. Okay, first we need the data of the houses. Okay, so what is the square foot, number of rooms, the features, the garden we want, balcony we want. Depending on that, on what area we are gonna use supervised learning, and we can calculate what is the price of that place. Okay, so let me give an example. If you go to HSR, the price may be different, and if you come to the village side, the price may be different. So why it is that? Because the land, all the comfort zone we have, right? So what is the you can see the prediction of houses. So what all you need? So I'm saying I need 4 rooms, I need some balcony and everything. So it depends on cost also, right? So you're saying all the things you needed and what is the prediction of house. So how to predict that? You can always use a supervised learning. Okay, we're gonna predict for houses. Okay, what will be the cost for everything? Okay, so some will be saying, sir, why it is called as supervised learning, right? So it is called supervised learning, guys, because of its algorithms. Okay, so because of algorithms that can learn from training data set and can be thought of as a guide supervising the learning process. Okay, so basically because of the algorithms, guys, that learning from the training data set, and it can be thought of a guide, so supervising with learning process. Okay, so basically that is the reason why we are going to call it as supervised learning. Okay, so guys, what is a common example if you ask me? So this supervised learning. So some of this popular supervised learning, guys, this machine learning algorithms uses linear regression problems, okay, random forest. So I'm going to explain that also. This. So basically, we'll be having a question now: how to do this supervised learning? So you explain what you mean by supervised learning, why it is called as supervised learning. So what is meant by supervised learning? So the steps that are used for supervised learning, guys. So let me write it down for you. So the first one is prepare data. Okay. And the next one is choose an algorithm. What algorithm you're going to use? And next one is fit to a model. Fit a model. Okay. And the next one is choose a validation method. So which validation method you are going to use? As I said, guys, I'm going to explain what is meant by validation and all. So choose a validation method. And examine this, let me say, I can say it as until update until it is finished. Yes. Okay. Keep on updating. Update until you are satisfied. Okay. The model till you get a perfect thing. And after that, I can call it as after updating until you are satisfied, you can fit that model for prediction. Okay. Fit model for that predictions. Okay, so these things, guys. So if you ask me, sir, what are the steps involved for this supervised learning, right? So these 6 things, if we follow, guys, it is more than enough. Okay, these things only we follow when we are gonna do for this steps for supervised learning. Okay, so what we are gonna do, we are gonna prepare the data first. So after preparing the data, what we are going to do? We are going to choose an algorithm. So why to choose an algorithm? So you have to prepare the data. If you don't choose any algorithm, does that make sense? No, right? You have to choose then algorithm. Then you're going to fit into a model. Then you're going to do a validation method. So what is meant by fit into a model? So train and test we are going to do there, guys. So I'm going to explain that, okay? And validation method. So I know validation. So let me give you this thing where we can. It is to avoid information leakage. You can say a validation. What is meant by validation? The validation is nothing but where we can avoid information leakage. Okay, it is a third party model. So don't have to look there. What is validation? So that is what is meant by validation. And after that, update until you are satisfied. So I said, guys, overfit, underfit, and this fit model, we'll be getting that. So till you get satisfied, update until that. So after that, we are gonna send it for the predictions. Okay. So after that, if you can ask me, so is this supervised learning is easier? Okay, so you can ask that. So what is the first steps involved? Okay, you can see what all the first step is, guys. The first step is nothing but the prepared data. Okay, so why we need to prepare data? Okay, you know, without the data, can you apply the algorithms and all? No, right? So we're gonna prepare data. Right? So guys, supervised learning is nothing but it is also called as a supervised machine learning, and it is a subcategory of machine learning and artificial intelligence. Okay, so guys, I'm just giving a recap what I have taught you about supervised learning. Okay, so supervised learning is nothing but it is also called as supervised machine learning, and it is a subcategory of machine learning and artificial intelligence. Okay, okay, and it is defined by labeled of data sets, guys. So which has input and output. So guys, supervised learning is a labeled data set. What is meant by this labeled data? So what is meant by labeled data sets? Okay. So labeled data set is nothing but we can classify data and predict our outcomes accurately. Where we can classify data or predict outcomes accurately. Okay. As we are going to input data, okay, into a model, we are going to see what all things we are going to do. Okay. This supervised learning, guys, helps organizations basically to solve variety of real world problems. Okay. Such as classifying spam in separate folder for. So guys, when I say you can see in Gmail, you'll be having inbox, right? So in inbox, the messages which are not necessary will automatically go to spam. Sometimes the messages which you send to your friends, the message which is sent by your friends will automatically go to spam. So it is done by the supervised learning methods. Okay, it has solved so many real world problems. Okay, such as classifying spam is one thing, and we have separate folders that also, right? So this is all about supervised learning, guys. So if you have still more curiosity, how this supervised learning is gonna work. So supervised learning, guys, it uses a training set to teach models. Okay. So until it get a desired outcome. Okay. So I'm gonna explain you showing an image. Okay. So guys, before that, let me say you how this supervised learning works. Okay. Supervised learning uses a training set. Okay. It's going to teach models until it is desired out. Okay. The training data set includes input and correct outputs. As I said, guys, it is a labeled data set. Supervised learning is a labeled data set. Now, automatically, you'll be knowing what is meant by unsupervised, right? So, supervised is nothing but okay, it's unlabeled data. So, perfect, guys. What you said is perfect. Okay. Classification. Okay. Classification. So, guys, the labeled data sets. Okay. So, we have seen what is meant by supervised learning, right? So, the algorithms, we're going to maintain the accuracy. Okay. So supervised learning can be separated into two types of problems, guys. One is classification. Okay, so let me clear this for you. So supervised learning. So guys, this supervised learning, okay, supervised learning, guys. The supervised learning has two problems when data mining. Okay, we have classification, and next one we have is regression. Okay, so guys, what is this classification? Okay, so classification and regression, guys. Okay, so the supervised learning, as I said, we have different types, guys. Okay, the two problems in data mining we have classification and regression. Okay, this supervised learning. So guys, classification. What is meant by classification? So guys, classification, it is an algorithm to accurately assign test data into specific categories. Okay, it recognizes specific entities within the data set, and we're going to attempt to draw some conclusions. Okay, so this common classification algorithms, guys, this linear, this SVM, the decision tree. So I'm going to explain that. Okay, so what is decision tree and all. So just make sure what is meant by classification you understand, and what is regression. So guys, regression, okay, the first one is classification we have in supervised learning, and the second thing we have is regression. Okay, what is this regression? So regression, right? So regression. So regression, it is used to understand the relationship between dependent and independent variables. Okay, regression is used to understand the relationship between independent and dependent variables. Okay, it is common used to make projections, such as, like, I can say the scales revenue for a given case. Okay, what is our revenue for scales? And this linear regression, this logistical regression, polynomial regression. So we have different types of regressions. Okay, so in regression we have different types. One is linear, logical, okay, logistical, polynomial, and popular regression algorithms. So that are type of regressions we have. And if you ask in classifications, we have like common classifications like SVM, support vector emissions, decision tree, K-nearest neighbor classification, random forest. Okay, this supervised learning algorithms, guys. Okay, it has like computational techniques in supervised learning. Okay, uh, this neural network, navy bias, linear regression, logistic, SVM. Okay, so I'm going to explain that. So basically, I'm not gonna go now. So I'm going to go step by step, as I said. So that was all about this supervised learning. Okay, this supervised learning is all about. Okay, so guys, the next thing. So when you see here, guys, when I split the data, machine learning primer, you can see training, validation, and testing. So here, so let me go to the slides. So guys, the agendas we have seen. So data types, continuous, and everything. Measure of central tendency we have seen, right? So after that, why do we need this data processing? Okay. So why do we need this data pre-processing? So how we are going to implement on this? So these things we'll be seeing, guys. Okay. So guys, as I said, the validation. Okay. The validation and the training and testing. So how it is done? So guys, whenever I say whatever we are gonna build, right? So when you click on training, guys, you can see build the model, test on validation type, which is hyperparameters. Okay. So basically, guys, the first thing what we are gonna do in supervised learning is we are gonna train our model. Okay, the data which you have sent. Okay, the data which we have, we're gonna send it to the train. Okay, we're gonna train that data. Okay, after training the data, then we are gonna send it to the test data. Okay, the test data. So I'll show you the image, guys, and make sure you get the good idea of that. See the supervised learning. Okay, you can see supervised learning. Okay, training and validation, historical data, and after that we are going to do random sampling. Right, after random sampling, training data set, again this validation and everything. Okay. So guys, this supervised learning. So supervised learning, guys. Basically, the supervised learning has different type of algorithms, classifier, methods, and right. So what is this training data set and validation data set and random sampling? So guys, when I come here, right, the training data set and validation testing. So guys, I'm going to train my model. So as I said, I'm going to send my data to training the model. Okay. Train the model, I'm going to send. Okay. So here, the training model first only learns some mathematical, all the mathematical things, right? So because I'm sending my data, it's already learns the patterns and do some mathematical equations. And after that, I'm going to send it to the test data. Okay. The test data. Okay. The same thing here, guys. What I showed you, right? Here, the same thing. Okay. Training and validation. I'm going to training and data set. So I'm going to explain you more simple. Okay. After training data set, guys. Okay. 80% almost the training set has learned. The remaining 20%, we are going to send it for the test data. Okay. And after test data, again, we're going to get it for the training. So before this exchange, guys, there will be a validation. Okay. Why we need this validation? To avoid information leakage, guys. Okay. To avoid any information leakage, we are going to use validation. Okay. And it is a third party model. Okay. Okay, guys. This is how we are going to train our model. Okay. Basically, I'm going to go more deep about this training and test data. Okay. So, guys, as I was explaining about training and test data, so we have seen how we are going to send our data. 80%, 20%. Sir, I'm still in loop. So, guys, let me explain you that. So when our train data and test data both are high, okay, train data and test data both are high, guys. When both are high, means which is good. It is called as right fit model. Okay, this both is called as right fit model. Okay, right model, right fit. Let me write it right fit only. Right fit model is when trained data and test data both are in having good accuracy and maintaining everything. If both are high, then it is called as a right fit model. So let me say now the train is high because we are going to send 80% right here and the test is low. What is it is called? So when train is high and test is low, guys, it is called as, okay, so let me change. Okay. Okay. So when this train is high, okay, and test is low, what we are going to do, it is called as overfitting or bias, guys. Overfitting or bias. So what is overfitting or bias? Okay. So overfitting or variance. Variance. Okay, it's overfitting or variances. So what is overfitting? Okay, why do we get this overfitting? Is guys, you have an idea. So why do we get overfitting? We get overfitting because my train data is high and test data is low. So that is the reason I am getting overfitting. So overfitting is a concept, guys. Basically, you can say in a data science. Well, I know I'm explaining data science. So overfitting, guys, is the production and analysis that corresponds to closely or exactly to particular set of data. Okay. So to avoid this overfit, so what is overfitting? We have seen. So why do overfitting occurs, guys? Because when trained data is high and test data is low, we are gonna get this overfitting or variance. Okay. So what is this overfitting? So overfitting, the production of an analysis that corresponds to closely or exactly to a particular set of data and may therefore fail to fit in additional data. So okay, it's going to predict futures. Okay. So in simple words, if you ask me what is overfitting? Overfitting occurs when the model cannot generalize and fits too closely. Okay. So what is this overfitting, guys? Overfitting occurs only when the model cannot generalize and fits too closely, okay, to the training data set instead. Okay. When the model cannot fit in the training data set. Okay. Overfitting happens due to several, okay, due to several reasons, I can say. This overfitting may occur, the training data set is too small and it does not contain enough data. Okay. And the samples are not accurately present and all the possible this input data values. Okay. That is overfitting. So what is an example for an overfitting, right? So if our model does much better on training set than on test data set, then we are going to call it as overfitting. Okay. So what is that? If our model does much better on training data set than test data set, then we are going to call it as overfitting. For example, it would be big. Okay. Basically, I'm going to say different types. Okay. So how do we prevent overfitting this? Okay, we are going to do data augmentation, feature selection, cross validation. Okay, basically I'll explain to say regularization. Okay, to solve this, I'm going to use a technique called regularization. Okay, what is regularization? Which basically fits a model into training data set to avoid overfitting. Okay, it's going to basically fit a model on overfitting to basically it's going to fit a data set in overfitting to avoid overfitting. Okay, and after that we are going to see if both are low. So you have said high and low. If both are low, what is the condition? Then it is called as, guys, it is called as underfitting or bias. Okay, underfitting or bias. So what is this underfitting? Okay, when both are low, guys, when this both train data and test data both are low, is called as underfitting. Okay, so guys, underfitting. When I say underfitting, so basically consider it is a scenario in data science, guys, when a data model is unable to capture the relationship between input and output variables. Okay, it's going to generate a high error, guys, in both training data sets and unseen data. Okay, what causes this underfitting? So, what causes underfitting, guys? The answer is in front of you, right? When train data is high and test data is when train data is low and test data is low, automatically underfitting occurs. Okay. When a model hasn't learned anything, I can say that. Okay. When model hasn't learned any patterns in the training data, well as unable to generalize well on the new data. Okay. So I can say basically when model hasn't learned anything, we are going to see underfitting or bias. Okay, guys. So after that, we're going to see what type of bias we have. Okay. Underfitting occurs due to high bias and low variance. High bias and low variance. So what is an example for underfitting? So if you ask any example, guys, okay, when we don't have enough, this what we say, enough parameters to capture the trends in underlying system, then we can go for underfitting or bias. Okay, guys. So underfitting or bias, how to prevent this, right? The next thing will be how to prevent this. Nothing bias, we're going to transform the data or we're going to do EDE. Okay, we're going to keep on doing that until we are satisfied. Then we are going to solve this underfitting or bias. Okay, so this is what is meant by right fit model. If both are good, guys, if train data is high, test data is high, then it is called as right fit model. Okay. Overfitting or variance is nothing but when test data is train data is high and test data is low, is called as overfitting or variance. Okay, so guys, moving on, we'll be seeing what type of data we have. So we have seen what is meant by that. Okay, the next thing we'll be seeing is the testing, the unsupervised learning. So guys, I hope what is supervised learning is clear. We have seen different type of supervised learnings, right? So guys, we have seen different type of that. And the next thing we'll be seeing is what type of data. Okay. So guys, the overfitting or underfitting. This overfitting or underfitting. Basically, it's gonna occur. You can see what are the answers you can give, right? So guys, after that, we are gonna go for validation. Okay. So what is validation? It's nothing but a third party model to avoid information leakage, I can say. So auto hyperparameter tuning, we have different type of validations, hyperparameters, right? Grid search, random research search, and different types. And after that, I'm going to compare the training and testing error. Okay. See the right fit. If both training and testing error are low and close to each other, then it is called as a right fit. Okay. When error are low, in the sense, guys, here I have said if both are high, the same thing. Okay. Don't have to get confused. If training error is low and testing error is high, then it is called as overfitting. It's the same thing. Training is high, testing is low, then it is called as overfitting. Okay, guys. If both are low, it is called as underfitting or bias. To fix this, we are going to use a regularization thing. So regularization thing, but where we are gonna, it's gonna fit a data set into a model. Okay. So guys, the same thing. Okay. Here, it's nothing but we are gonna go with when training error is low. Okay, and testing error is high. In the sense, guys, the same thing you can write it. Okay. So here I'm gonna say trained data has learned nothing and tested data is giving higher grades. Then we are gonna call it as okay. So guys, after that underfitting or bias also we have seen, right? So when you click on underfitting or bias, guys, you can see to fix this problem, we are going to do data performance. Okay, as I said, guys, feature engineering or get more observation or EDA, transform the data. Okay, what is very much convenient for us. Okay, so after that, we'll move on this. So supervised learning is, so when you click on your predictive modeling, so let me explain about this classification models. Okay, binary, what type of classifications we have? We have binary classification, multi-label, categorical probability. So binary is nothing but one, guys, you know that, right? So I'm not going to go more deep into this. So classification models we have in supervised learning, we have binary classification, multi-classification, multiple label classification, and many. Okay, and the next thing we have shallow machine learning models. Okay, so we have navy bias, k nearest neighbors. Okay, so these things we have is navy bias and probabilistic learning. Okay, so what is shallow machine? Why we are going to use this? Okay, these things we'll be seeing. Okay, the shallow learning methods, the models, and after that we're going to go for ensemble models. Okay, what is ensemble models? See, we have complete detail about ensemble models. Okay, the boosting, ada boost, bagging, sampling, resampling. Okay, all types we have in ensemble models. Okay, and regression models, guys. We have different type of regression models, guys. Okay, simple linear regression, multilinear, non-linear, simple logistic. Okay, which has one dependent, one independent variable. Okay, what is meant by simple linear regressions? Okay, so as I said, guys, if you are more curious, you can always go ahead and just read mind map. Okay, you'll get all the details. You don't have to go and search anywhere. You will get the code. Okay. So guys, regression models we have seen. So moving on, we'll be seeing the black box techniques. Okay, we have SVM, neural network. Okay, what is meant by that? And what is automatic feature engineering? Okay, what are the disadvantages? So guys, after that, we'll be seeing the unsupervised learning, right? We have seen supervised learning. So unsupervised learning is nothing but, guys, just it is nothing but which is unlabeled data sets. Okay. So clustering segmentations. So guys, let me explain you about unsupervised first, right? So we have seen what is meant by this. So unsupervised learning is. So let me write it down for you. So choose. Okay, guys. So unsupervised. Let me take it is a little dark, little light. Let me take something dark. Okay. Unsupervised learning. So guys, unsupervised learning, it is a type of algorithm, guys, which learns patterns of untagged data. Okay. It is an unsupervised learning. Is a type of algorithm that learns patterns from untagged data. Okay, that it's gonna hope to mimicry, which is important learning in model. Okay, like this, I can say the machine is forced to build a this representation of word. Okay, imagination of content. Okay, what is meant by unsupervised learning? So, guys, as I said, supervised learning is also called as supervised machine learning. The same thing here also says. What is unsupervised learning? Unsupervised learning is also known as unsupervised machine learning, okay, which uses machine learning algorithms to analyze and cluster unlabeled data sets. Okay, it's going to use machine learning algorithms to analyze and cluster unlabeled data sets. These algorithms usually discover the hidden patterns or data groupings without the need for human intervention. Okay, without any human intervention, we are going to use this unsupervised learning. So, guys, as I said, unsupervised learning, okay, unsupervised learning is nothing but machine learning algorithms where we are going to analyze and cluster unlabeled data sets. Okay, the algorithms we're going to discover hidden patterns or data groupings without the need of any human like I can say human interference. Okay, without any human interference, it's gonna discover the hidden patterns or all things is gonna done by unsupervised learning. So unsupervised learning but unlabeled data. So what is unlabeled data? So guys, unlabeled data means where it's nothing but we're going to get only the output equations. Okay. So unsupervised learning, guys, it's going to provide a set of unlabeled data, okay, which is required to analyze, find patterns. Okay, we're going to find patterns and we're going to analyze what is the patterns inside. The example for this are dimension, like dimension reduction and clustering. So you can see hierarchical clustering and everything, right? So that are the things. Okay, guys. So, so guys, after that, we are gonna see what are the concepts. Okay. So guys, what is the difference between? So before going to the difference between guys, the supervised and unsupervised, let me explain you about why is this supervised learning used. Right? You can go to the difference, guys, but let me explain you about why this supervised learning is used. So, guys, unsupervised learning is helpful for finding useful insights from the data. Okay, this unsupervised learning is nothing but lies. It is much similar to human learns. Okay, it's gonna like human learns in the sense to think by their own experiences. Okay, which make it closer to the real AI. So basically, guys, I said I think like it's basically it's gonna learn the similar things of humans. Okay, so make it own experience. Okay, this unsupervised learning, guys, works on unlabeled data and uncategorized data, which makes unsupervised learning more important. Okay, basically learns on uncategorized data, okay, and unlabeled data. Okay, guys, what is this? Why we need this unsupervised learning, right? So, guys, whenever I say unsupervised learning, it's all about unlabeled data. Okay, so unsupervised learning, we know it uses machine learning algorithms. Okay, and we're going to analyze using cluster and unlabeled data. These algorithms, what it's going to do, it's going to discover hidden patterns or data groupings. And we're going to see the difference in information to make ideal solution for expert data analysis, cross-selling strategies, customer segmentation, and more. So, okay. So, guys, common unsupervised learning approaches, if you ask me, the dimension reduction, I said this. Okay, so that is what is meant by this unsupervised learning, guys. So I hope everyone are clear what is meant by this unsupervised learning. Okay, so guys, unsupervised learning, it also refers to the use of AI algorithms to identify patterns in the containing data points. They're classified. Okay, so so the next thing, sir, what is the difference between supervised learning and unsupervised learning? So I hope everyone has seen one difference, the labeled data and unlabeled data. Okay, labeled data in the sense which we have both input and the output, right? And in supervised learning, it is unlabeled data. What is the output? Okay, so guys, in supervised learning, if you ask me difference, input data is provided to model along with the output. Okay, input data is used to model along with the output. In unsupervised learning, only input data is provided to the model. Okay. In unsupervised learning, only input data is provided to the model. Okay, guys. So the goal of the supervised learning, right? The goal of the supervised learning model is to train the model so that it can predict the output when they given new data. Okay, that is a difference, guys. So basically, supervised learning is going to train the model so that it can predict the outcome. Okay, when it is given the new data. Okay, guys. So that is a difference between supervised and unsupervised learning. So if you ask me, what are different types of this unsupervised learning? So we have, guys, okay, we have two categories, clustering and association rules. Okay, so basically I can call it like that. So this clustering is unsupervised learning technique, okay, which groups unlabeled data based on similarity and differences. Okay. So after that we have hierarchical clustering. So guys, hierarchical clustering. So this unsupervised learning, guys, the clustering segmentation you can see we have hierarchical clustering. So in hierarchical clustering, we have agglomerative and divisive, bottom to top approach, top to bottom approach. So before explaining that, what is hierarchical clustering, right? So guys, in data mining and statistics, the hierarchical clustering is a method of cluster analysis. Okay. So guys, when we are going to do clustering, guys, in tomorrow's session, we are going to do clustering. So I'm going to explain you there about this hierarchical clustering. Okay. When I show you the code, right? So it makes sense for you. So I'll remember everything. So, okay, this is the thing we are gonna apply here for automative analytics. So I make sure we'll go through that tomorrow as we are going to proceed with the course too. Okay. So guys, as to get to know, in hierarchical clustering, we have two different types, guys. One is agglomerative and divisive. Okay. And the next one is partition based clustering. Okay. And density based clustering, grid based clustering. Okay. Evaluation techniques, reduce the number of rows. This is cluster segmentation. Okay. In unsupervised learning, all this descriptive model, we have this clustering segmentation and dimension reduction. So linear patterns are handled by. So what is this dimensional reduction, which is going to reduce the dimensions? Okay. Non-negative factorization, independent analysis, as I said, guys, right? Principal component analysis, then and this ICA, independent component analysis. So here you can see. So there are patterns handled by. Okay. So you can see SBD, single value decomposition. What is the applications, right? So if you click on application, recommendation system, network analytics, and image processing. So guys, recommendation system. So I'm going to give a quick thing about that. So recommendations, recommendation system. So what is recommendation system? So basically, let me say, when you're gonna see something, guys. So let me say you're gonna buy some dress, okay, some dress for someone. So basically, this Flipkart recommends for you something, right? So okay, this type of dresses we have bestseller recommendations, right? So when you're gonna search something to eat or search something to buy, it will always get a recommendation things, guys. Okay, buy this. Okay, it's comparable to that. This will look into everything. So how it is done? Okay, so when you're gonna search for something, like let me say you're gonna search for a laptop, okay, you'll get different type of recommendation. Why is that? Because of this recommendation engine, guys. It's gonna suggest you, okay, these type of these things we have. Can you look into it? Okay, that is called as recommendation system. So network analytics, which has each and every node. Okay, it's gonna have a root nodes and everything. So we're not going to go deep in that. So just recommendation system, you can just see in your mobile, guys, whatever you search. Okay, so that is recommendation system. And the Python code, if you're gonna ask me, okay, the packages what you have is C, the decomposition thing, okay, the function, if you ask what is the function of these things, okay, this SVD data and the parameters, okay, so I'm not gonna go here more deep. And the next thing we have is principal component analysis. So what is this PC? We are going to use to convert large number of features into fewer features with sum of laws of information. Basically, we're going to use this PCA to convert large number of features into fewer features or some laws of information. Okay, the application, and is also called as feature extraction, not feature selection. Okay, it doesn't work. The raw data is uncorrelated features. Okay, it has some restrictions, you can say, guys. So where does this PCA is gonna work? Okay, how it is gonna work, and we're gonna convert large number of features. Okay, so guys, this is what is meant by principal component analysis. Okay, so principal component analysis, guys, we have seen this, and we have seen feature selection. So if you want to see the packages, guys, what is the packages we are going to use is sklearn or decomposition. Okay, the function. If you click on function, you can see the PCA. What is this PCA and all? Okay, so factor analysis is nothing, and the factor analysis is also called as attribute-based method. Okay, so why it is called as attribute-based method? Because it has 7 steps, guys. Okay, how we're going to identify the competitors. Okay, competitor database and everything, and more. Okay, and the next one is association rules. So this association list is also called as market basket analysis, affinity analysis, and relationship mining. So what is meant by association rules? So guys, association rule is nothing but where we are going to use this rules. Okay, this like let me say this market. It is also called as market basket, affinity, and relationship mining. Why it is called as like this? What is this association rule says? So association rules, guys. So association rules is mining. It's gonna find interesting. So if you ask me what is meant by that, okay, let me say then the statements that help to show probability relationship. Okay, it's gonna let me say in simple terms I can say that help to show the probability of relationship between data items within large data sets into various type of databases. Okay, the relationship between the data items with large data sets into various type of data sets. Okay, so that is the reason it is called as market basket analysis, affinity analysis, and relationship mining. And a priori algorithm. So the performance measures, okay, the support, the confidence, the lift ratio, the conviction, okay, that is of association rules and the sequential pattern mining. And the Python package, if you're asking me, is ML extend the frequent dot patterns. The function is appropriate and association rules will be having in that package. And the next one we're going to see is recommendation system. Recommendation system, guys, as I said, right? The what we're going to get. So we have seen that. And text mining, guys, if you go for text mining, we're going to see unstructured data, textual data, the feature extraction, okay, sentiment and semantic inputs, emotion mining, and many more. Okay. The same thing here also, guys. We have in classification models for this supervised learning also, the binary classification, multi-classification, multi-label, categorical, and category probability. Okay. This type of things we have in classification models. Okay. So guys, the classification models we have seen, the categorical probability of classification output, and what is this shallow machine learning models, right? So naive Bayes, the k nearest neighbor, divide and conquer. Okay. So the regularization technique is called as okay. Okay, what is this k nearest neighbor is also called as memory-based reasoning, example-based reasoning, instance-based reasoning. Okay. So we'll be seeing this k nearest neighbor and k means, guys. Okay, when you further move on. And if you go for ensemble models, see, guys, random forest, ADA, boost, everything. I have explained you this all, right? Means in the sense, I have given a quick this thing. Okay. So, guys, this was all about unsupervised learning and supervised learning. So basically, guys, what you have to understand in this unsupervised and supervised learning is nothing but, guys, in supervised learning, basically, we're gonna get the labeled data sets. Okay, we're gonna predict the output. But in unlabeled data sets, only output. Okay, so that is the reason, guys, we use this unsupervised learning or this descriptive. Okay, so guys, after that, we are gonna see the recommendation system, the association rules, this dimensional direction. So what is our next topic? We are going to implement this k means or k regarding that. Okay, so we'll be seeing that. Okay, the association rules and everything. So guys, I hope you have understood what is meant by this supervised learning and unsupervised learning, guys. So guys, in model building, we'll be having these type of things. Okay. So what is the supervised learning and unsupervised learning? We have seen the difference and everything. Right? So supervised learning, guys, it is nothing but it's going to contain this labeled data set. Okay. So if you ask me difference, can you give me difference between supervised learning and unsupervised learning? right? So we have so many concepts here, guys. So in supervised learning, input data is provided through model along with the output. Okay. In unsupervised learning, only input data is provided. Okay. So supervised learning, basically, I can say, guys, a teacher is going to teach. I'm going to teach you, and you are going to learn. That is called as supervised learning. For better example, if you ask me simple example, I'm a trainer. If I'm going to teach you, that is supervised learning. Unsupervised learning is nothing but where you're going to study by yourself. Okay. That is called as unsupervised. Okay. So just to make you more things, okay, that is called as. So what happens in supervised learning? Okay. Okay. This supervised learning is nothing but where we can let me say I'm going to teach you and I'm going to force you to learn. That is supervised learning. Unsupervised learning, self-sufficient. Okay, you're going to learn by yourself. That is meant by this unsupervised learning. And reinforcement learning, it's different. It's okay. It's going to learn by itself. Basically, in the environment, it's going to see the environment and it's going to learn by itself. Okay, I can call it as it rules, my life, my rules, right? The content you have seen, life, my rules. The same thing is going to apply for reinforcement learning also. Okay, it's going to just learn the things what's there. Okay, so that is the difference between the supervised and supervised and everything, guys. Okay, so if you ask me the examples for this supervised learning, right? The example of supervised learning. The examples, guys, for the supervised learning is nothing but we have decision tree, we have logistic regression, okay, and we have linear regression. Okay, and SVM tools, support vector machine. So these are the example for supervised, most common used, guys. And if you ask me for unsupervised, right? So guys, unsupervised machine learning, the examples, if you ask me, K means clustering. So that guys, tomorrow I'm going to explain you about K means clustering. Okay. And we're going to go for hierarchical. And we'll be having a priori algorithm. Okay. So these type of examples I can give us for supervised learning and unsupervised. Okay, decision tree linear regression for supervised learning and unsupervised K-means clustering hierarchical. Okay, I'm going to explain what is meant by hierarchical clustering, these things and everything. Okay, so guys, so in today's session we have seen everything. Okay, so we have covered what is meant by machine learning, different type of machine learnings. We have seen what types are there. Okay, so I hope it was clear for everyone, guys. So day 1, day 2, day 3. It is done explaining about the concepts and all things. Okay. In day 4, we'll be seeing how we are going to implement the data which I have got, right? The data which I have created, how we are going to implement in automative analytics. So what we are going to learn there. So in this automative analytics, when I implement these things, so what is the result we are going to get? Okay. So in tomorrow's session, we'll be seeing that, guys. So make sure you attend my session. So it will be very exciting to learn new things, right? So make sure, guys. Okay. In case if you have missed any session, I recommend you to go and watch the recorded videos. Yes. Okay. Thank you for attending, guys. We'll see you tomorrow.